Namaskar. So in last lecture we discussed definition of press and different types of press operations. Also we discussed spring back action. Then we discussed press working equipments and rating of press. In today's lecture we will discuss press tool components and some arrangements. Also we will discuss press working terminology and different types of dies. So press tool component may be divided into different types, that is working components, structural components, guiding components, feeding components, locating and locking components, stripping components and fastening components. This figure shows the basic press. So working components which participate in the shaping of parts. So dies, punches and their sections. These are working components. Then structural components which serve for joining the working component to one another and to the press. So upper shoes, that is punch holder, and lower shoe, that is die holder, and shunts are structural components. Then third is the guiding components which ensure accurate alignment of upper shoe with the die shoe in operation. So guide posts, bushings, these are guiding components. Guide posts also facilitate tryout of the press tool in a press. Then feeding components. These are which feed the stock strip or blanks to the stamping station. Then locating and locking components which provide for an accurate positioning of the stock or blank in the die and fix it in place while the operation is performed. Then stripping components. What are stripping components? Which strip or remove the blanks and scrap from the working component after the operation is over. Strippers, bush of pins, knockouts. These are examples of stripping components. Then last is the fastening components which join and hold together all parts and units of the press tool, that is punch plate, die blocks, cases and all fasteners. So this figure which is showing on a screen is a schematic representation of a press tool comprising all principal components present in any typical press tool. The shank secures the press tool to the press ram. It fits in the clamping hole in the lower end of press ram. So in spite of the great variety of press tools, most of them have certain components similar in purpose and design. So to facilitate design, manufacture, maintenance and repair of press tool, similar units and components have been standardized. The most important standardized component of press tool is die set. So die set is very important. So which consists of upper shoe. So this is die set. This is just diagram of die set. You can say it is a commercial die set. So which consists of an upper shoe which is called punch holder, and lower shoe which is called as die holder, and guide posts. Punch or punches is mounted on the upper shoe and the die components are mounted on lower shoes or die shoes. The available space for mounting punch and die component is called die area. The die area on the lower shoe should be at least 6.35 mm larger all around the die block. Ears are provided on a flange of the die shoe to fasten it to the booster plate or the bed of the press. So in smaller die set, upper shoes are made with chunks. On longer die sets, the standard shoulders chunks are pressed, fitted into specially bored hole of upper shoes. So here the arrangement is shown in drawing A. Here drawing and bending press tools, threads, chunks are used. In case of B diagram, there are other arrangements also for fitting the chunks into the upper shoe of larger die set. If the tool chunk does not fit into the press slide hole, adapter chunks or split adapter bushings may be employed. The various arrangements of guide posts are back post design. So here it is a back post design. So in this back post design, the die set has two guide posts positioning in a rear part. So this is mostly frequently used design. So this design gives clear view of moving parts and there is no obstruction from guide posts. So this helps the operator when feeding from left to right. So this design also leaves a clear space for hand feeding blanks for second operation. The next type of arrangement of guide post is axial post. So axial post or sometimes center post. In this design, two guide posts are positioned along the transverse central line of die set. This figure shows this design is suitable when load is too heavy and the strip feeding is from the front. So this design prevents end feeding. So next type of arrangement of guide post is diagonal post design. You can see in the diagram. So this design is used when load is very heavy and end feeding is required. The guide posts are along a diagonal line. Generally the left guide post is in a front, but if feed is to be from left to right, the right guide post is in the front. So this is about diagonal posting. It is used in heavy. If load is very heavy, then it is used diagonal posting. Then 4 guide post design. So you can see the 4 guide post design shown in the figure. In this design, a guide post is positioned at each corner of the die set. This design provides maximum rigidity and accuracy of alignment. This design is used for large, very complicated and highly accurate stamping and for multi-station progressive dies. So this is about arrangement of guide posts. So we discussed back post design, axial post design, diagonal post design and 4 post design. So there are various arrangements of guide posts. So guide post, it is used to guide and locating. Now, how to select press? So the factors which should consider while selecting a press for a given job are the overall work size, the stock thickness and materials, kind of operation to be performed, power required and speed of operation. For punching, blanking and trimming operation, usually crank or eccentric type mechanical press is used. So this is due to their small working strokes and high production rate. In these operations, there is sudden release of load at the end of the cutting stroke. So this sudden release of load is not advisable in hydraulic press. So hydraulic presses are not preferred for these operations. If however there are inevitable, then some damping devices are incorporated in the press design. For coining and squeezing operation which require very large forces, knuckle joint mechanical press is ideally suited. Hydraulic presses which are slower and more powerful can also be used for these operations. So hydraulic presses are also better adapted to pressing, forming, drawing operations which are basically slow processes. Let us discuss press working terminology. This figure shows a cutting die used for punching and blanking operation. So let us discuss the components in detail. You can see in a diagram. So bed. So bed is a lower part of a press frame that serves as a table to which the bolster plate is mounted. Then bolster plate is second one. So this is a quick plate. This is a thick plate secured to the press bed, which is used for locating and supporting the die assembly. It is usually 5 to 12.5 centimeter thick. Then die set. It is a unit assembly which incorporates a lower and upper shoe, 2 or more guide posts and guide post bushings. Then die. So you can see the die. The die may be defined as a female part of complete tool of producing work in press. It is also referred to complete tool consists of pair of mating members for producing work in a press. Then die block. It is a block or plate which contains a die cavity. The lower shoe. It is a die holder. The lower shoe of a die set is generally mounted on a bolster plate of a press. A die block is mounted on a lower shoe. Also, the guide posts are mounted in it. Then punch. You can see in a diagram there is a punch. This is a punch. So, this is the male component of die assembly, which is directly or indirectly moved by and fastened to the press ram or slides. Then upper shoe. So this is upper shoe. So this is the upper part of the die set which contains guide post bushing. Then punch plate or punch retainer fits closely over the body of the punch and holds it in proper relative position. Then backup plate. This is a backup plate. Backup plate or pressure plate is placed so that the intensity of pressure does not become excessive on punch holder. The plate distributes the pressure over a wide area and the intensity of pressure on the punch holder is reduced to avoid crushing. Then next is a stripper. What is a stripper? It is a plate which is used to strip the metal strip from cutting or non-cutting punch or die. It may also guide the sheet. Next is a knockout. Knockout, it is a mechanism used connected to and operated by the press ram for freeing a workpiece from die. So there is one connecting rod known as pitman, which is used to transmit motion from main drive shaft to the press slides. Then one more thing is important here, the height and stroke. What is height? So shed height. Shed height, it is a distance from top of the bed to the bottom of the slide with its stroke down and adjustment up. What is stroke then? The stroke of a press is a distance of ram movement from its up position to its down position. It is equal to twice the crankshaft through or the eccentricity of eccentric drive. It consists of the crankshaft eccentric drives but is variable on hydraulic press. So this is about the working terminology of press. Let us discuss how cutting dies are working. As it is clear in a figure, okay, the punch holder, that is upper shoe, is fastened directly to the ram of the punch press and the die shoe is fastened to the booster plate of the press. So guide post may be used to better align the punch holder with the die shoe. So these main components, punch holders, die shoe, guide post, constitute of what is known as die set. Okay, so punch holder, die shoe and guide post constitute is known as a die set. A die set can be had with the two guide posts located at rear of the die set is known as a back post. Diagonally, so one at the back and other in front of the die set or with four guide posts. We discussed already different types of guide posts. That is four guide post, diagonal post, center or axial post and back post design. So here diagonally, one at the back and other in the front of die set or with four guide posts, one in each corner of the die set. The lower end of the guide posts are press fitted into the die shoe. At the upper end, the guide posts have a slip fit with the guide bushing, which are press fitted into the punch holder. With this, the guide posts have free movement in the bushing. The punch is fastened to the punch holder and the die block is fastened to the die shoe. The punch is aligned with the opening in the die block since both the punch and die block act as cutting tool. Okay, these cutting tools are hardened. So in figure you can see the working of cutting die. The cutting action takes place during the downward movement of the punch into the die block. After the cutting action, elastic recovery in the strip material takes place. Due to this, the size of blank increases and that of the hole in the strip decreases. So, at the end of cutting action, when punch starts move upward, the scrap strip clings to the punch and the blank gate clogs in the die opening. To remove the scrap strip from the punch surface, the stripper is used. The simplest type of stripper is used. It strips off the scrap strip from the punch surface when the scrap strip strikes the bottom surface of stripper during the upward movement of the punch. To avoid clinging of the blank in the die opening, the wall of die opening are tapered. Why die openings are tapered? To avoid clinging of blank in die opening. In addition to the two above mentioned troubles, the blank may also adhere to the face of punch. So this usually happens when thin blanks which have been treated with lubricant to help the blank free itself from the punch face. Push-up pins are provided which are fitted into the punch body. So various designs of push-up pins are shown in figure. The most popular design is straight round plunger with the sliding feet. So in first diagram, A diagram you can see. So most popular design is a straight round plunger with a sliding feet in the punch body. So it holds a place by a light compression spring and a set screw. If at the end of the punch body a pilot is to be provided, then the push-off pin is located off center. The second case, so when the space available for comprising spring is insufficient, a flat spring may be used. So there are different types of push-off pins. Then punch face counter. So in case of very small punches, no space is left to provide the push-up pins. In such case, the sticking of blank to the punch face may be avoided by changing the shape of the punch bottom. So here the oil seal or vacuum created by oil film is broken and tendency of the blank to stick to the punch face is greatly decreased. The drawback of this method is that the blank gets distorted. So due to this method is suitable for punching operation only. So the punch face contour to prevent blanks from sticking to very small punches. So these are several sections and shapes of punches. It is called punch face contours. Is it clear? So what we discussed? So today we discussed different press components. There are several types of components: working components, structural components, guiding components, feeding components, locating and locking components, stripping components, and fastening components. Then we discussed different building of press tool, that is commercial die set. Then arrangement of guide posts we discussed. There are different 4 types of post: back post design, axial post design, diagonal post design, and 4 guide post design. Then on which base you can select a press. Press selection. Also we discussed press working terminologies, different terminologies used in press working. Then how cutting dies work, working of cutting die, then push-up pins and punches face counters we discussed. Now let us move to different types of dies. What are different types of dies? So die may be classified according to type of press operation and according to the method of operation. So type of press operations. According to this criterion, the dies may be classified as cutting dies and forming dies. So the major classification is cutting die and forming die. Cutting die and forming die. What is cutting die? So cutting dies are used to cut metal. They utilize the cutting or shearing action. The common cutting dies are blanking dies, piercing dies, perforating dies, notching dies, trimming dies, shaving dies, and nibbing dies. The second type of dies are forming dies. So these dies change the appearance of the blank without removing any stock. So these dies includes bending dies, drawing dies, squeezing dies. Now let us discuss method of operations. So depending upon the method of according to this criteria, that is method of operation, the dies may be classified as single operation die, or it is also called a simple die. This is simple die. Then compound dies, combination dies, progressive dies, transfer dies, and multiple dies. So according to the method of operation, so dies are classified as single operation die, or compound dies, combination dies, progressive dies, transfer dies, and multiple dies. What is simple die? So single action die. Simple die is a single operation die which performs single operation for each stroke of press slide. The operation may be any of operation listed under cutting or forming die. Then second is compound die. In these dies, two or more operation may be performed at one station. Such dies are considered as a cutting tools, since only cutting operations are carried out in compound dies. So figure shows a simple compound die in which the washer is made by one stroke of the press. So washer is produced simultaneously blanking and piercing operations. So compound dies are more accurate and economical in mass production as compared to single operation die. Then next operation is combination die. What is combination die? Here in combination die, so more than one operation may be performed at one station. It differs from compound die in that in this die, in combination die, a cutting operation is combined with bending or drawing operation. Means here cutting operation and non-cutting operations are combined. That's why it is called combination die. So figure shows, I'll show one figure. This is a combination die. So figure shows the working of combination blank and drawing die. So die ring, which is mounted on the die shoes, is counterbore at the bottom to allow flange of a pad to travel up and down. So this pad is held flush with the face of the die by spring. The drawing punch of required shape is fastened to the die shoe. So blanking punch is secured to the punch holder. A spring stripper strips the skeleton from blank punch and knockout extending through the center opening. So this is about combination die. Okay, and through the punch stem ejects the part of the upstroke as it combines in contact with the knockout bar on the press. So in operation, the blank holding ring descends as a part is blanked. Then the drawing punch contacts and forces the blank into drawing die, which is made in the blanking punch. So this is about combination die. What about progressive die? A progressive or follow-on die has a series of stations. At each station, an operation is performed on a workpiece during a stroke of the press. Between stroke and a piece in metal strip is transferred to the next station. A finished workpiece is made at each stroke of the press, a progressive die. You can see in a figure. While the piercing punch cuts the hole in the stroke, the blanking punch blanks out portion of the metal in which the hole had been pierced at a previous station. Thus, after the first stroke, when only a hole will be punched, each stroke of the press produces finished washer. So this is a progressive die. I will show few examples and videos in upcoming lectures. so that you can understand the progressive dies. Then next is transfer die. Transfer die. Unlike the progressive dies where the stock is fed progressively from one station to another, in transfer dies the already cut blanks are fed mechanically through stations to stations. So progressive die in a single press machine it is carried out. In case of transfer dies, the one unfinished or semi-finished product is supplied or fed to the another machine and it is continued. These are called transfer dies. Then multiple dies. Multiple or gang dies produce two or more workpieces at each stroke of the press. A gang or number of simple dies and punches are ganged together to produce two or more parts at each stroke of the press. So this is about different types of dies. Today we also discuss a principle of metal cutting. So in next session we will discuss principle of metal cutting, and while metal cutting, what is required? A proper consideration of clearance is required. Then cutting forces are required. Then stresses in cutting. So study of stresses in cutting are required. So in next lecture we will discuss the principle of cutting, the clearance and cutting forces. So we will discuss in next lecture. Or today we will continue. So let us discuss this topic and then we will stop. Okay, no problem. We will continue the same thing in today's lecture only. Principle of cutting. So what is cutting? Cutting nothing but separation. The cutting of a sheet metal in a press working is shearing process. Okay, two parallel unlike forces. A cutting action is an explained in figure. You can see this figure. Okay, stress in cutting, initially stress, and then cutting action takes place. The punch is of the same shape as the die opening except that it is similar on each side of the component known as clearance. Clearance is there, it is not fit but it is a clearance fit, it is not transition fit. As the punch touches the material and travels downward, it pushes the material into the die opening. The material is subjected to both tensile and compressive stresses. The stresses will be the highest at the edge of the punch and die and material will start cracking there. The various steps in the rupture or fracture of material can be written as the stressing the material beyond its elastic limit, plastic deformation, reduction in area. The fracture starts in the reduced area and becomes complete. If the clearance between punch and die is correct, the crack starts from the punch and die edges will meet and rupture is complete as shown in figure. If the clearance is too large or too small, the crack do not meet and ragged edge results die to the material being dragged and torn through the die. So proper clearance is very important. So what is clearance? As it is clear in that die opening must be sufficiently larger than the punch to permit clean fracture of the metal. So this difference dimensions between mating members of die set is called clearance. So the clearance is applied in different manners. So one is when hole is to be held to size, the hole in a sheet metal is to be accurate, that is punching operation. The slug is to be discarded. The punch is made to the size of the hole and die opening size is obtained by adding clearance to the punch size. In case of blanking operation, where the slug or blank is desired part has to be held to size. The die opening size equals the blank size, and the punch size is obtained by subtracting the clearance of the die opening size. So this figure shows the slug is a scrap here, and here slug is a desired part. Okay, this is about clearance. Okay, it depends upon the type of operation again, either punching or blanking. Now, the clearance is the function of the kind and thickness, a temper of work material. Hard material require larger clearance than soft material. The exception being aluminium. The usual clearance per side of the die for various metals are given. That is brass and soft steel 5% of thickness, medium steel 6% of the thickness, hard steel 7% of the thickness, and for aluminum, even it is a soft, for aluminum 10% of the thickness. The total clearance between punch and die size will be the twice these figures. These clearances are for blanking piercing operations. So we must take a help of these notations while designing any die set, and we have to keep a clearance, proper clearance. So reason behind the application of clearance in the manner is the diameter of blank or punch hole is determined by the burnished area. On the blank, the burnished area is produced by the wall of die. Therefore, blank size will be equal to the size of die opening. Similarly, in punching operation, the burning operations are in the hole produced by the punch. Therefore, the size of the hole will be the same as the punch. So, therefore, the application of clearance on the punch and die will depend upon the punched hole or the cut blank is desired product. Hence, the punching operation, the punch is made to the correct hole size and die opening is made oversize and amount equal to die clearance. Similarly, if the blank is desired product, the die opening size is made to the correct blank size and the punch is made smaller and amount equal to the die clearance. In other words, punch controls the hole size and deep opening controls the blank size. In next figure, it is shown the section through blanking die. So this figure shows the section through blanking die. Here you can see the clearance hole, angular clearance, then die lower shoes, die blocks, straight, that is lands, punch, and solid stripper. What is land then? So it is a flat, usually horizontal surface contiguous to the cutting of die, which is ground and reground to keep the cutting edges of the punch sharp. Then what is straight? It is a surface of cutting die between the cutting edge and the beginning of the angular clearance. The straight portion gives strength to the cutting surface of the die and also provides the sharpening of the die. The straight portion is usually kept at about 3 mm from all materials less than 2 mm thickness. So for thicker material, it is taken to be equal to the metal thickness. So this is about straight. Then angular clearance is also important. So angular clearance or relief is provided to enable the slug to clear the die. It is provided below the straight. straight portion of the die surface, it is usually 1/4 or 1/4 or 1.5 per side, but occasionally it is as high as 2 degree. So depending upon mainly on stock thickness and frequency of sharpening, for round die opening, that is D is less than 3 to 5 mm instead of die angular clearance. Die clearance is maintained by slightly oversized drilling. So this is about angular clearance. So this is about clearance of die clearance. The punch and die clearance, after considering the elastic recovery of material, it has already been explained that after cutting operation has been completed, elastic recovery of strip material takes place. In blanking operation, after the release of blank pressure, the blank expands slightly. The blank part is thus actually larger than the die component, die opening that has produced it. It depends upon different types of operations. Okay. So in next lecture we will discuss cutting forces and other part of this chapter. Till that, thank you very much.